Alrighty, so computer basics. Let's define briefly what we mean by a computer. I'll have these lecture notes for you guys, like the actual Word packet notes. I'm going to get those printed out, so don't worry too much about taking every single note. But a computer, right? Any machine that can perform mathematical computations, manipulate information, and make decisions based on those computations and information input. So you get something that can take in input information, right? We're not a computer, but we're sort of in that same idea, right? We get input, right? Our nervous system specifically gets input from the world around us, and it integrates that information, does some computation in air quotes with it, right? And then gives you an output. Yeah, a computer is in a similar way that same type of thing, right? And I hesitate to say exactly because it's not, right? But a similar idea, right? There's an input to the computer, information goes in, it does a computation, and then you have an output from that. It does this by following, as it says, pre-programmed sets of instructions for specific tasks called algorithms. You guys will work with algorithms all the time, right? In medicine, we work with algorithms that tell us, like, if the patient has no pulse, right? Do this, right? If the patient does have a pulse, then do this other thing, right? That's an algorithm, okay? So we follow algorithms all the time. Computers are designed to follow algorithms as well. So a computer program, right, we know of the software that computers run, simply just a set of algorithms, a collection of hundreds of algorithms that allow the user to perform a general application. Examples include tax software. Everyone does their taxes, and most of us do them on computer. Does anybody do their taxes on paper and send them in? No, you guys all do them on the computer, right? Yeah, me too. So that's a computer program, right? Word processing. Heck, PowerPoint that I'm using right now is a computer program. Anything that you're going to do on the computer is a computer program. Organizing a database, all computer programs. Okay. So let's talk a little bit about some of the computer components. You are by no means going to be a computer expert by the end of this, but you will understand the basics of what computers have going on for them. So this will start with the central processing unit. This is as it says, it's the processing unit, but the main one, the central processing unit, or CPU. This is primarily what used to determine the size of computers, right? We now have microprocessors, so our computers can fit in our hand, right? Before the invention of the microprocessing devices, you had computers fitting in entire floors of buildings, right? Entire rooms. So it's the part of the computer that interprets and executes the instructions. We call that the CPU. Nowadays, as I said, the CPU is contained on a single integrated circuit chip we're going to call a microchip. That's an example of a microchip. Okay, computer power. The power of a computer in terms of how much data it can process. That's what's really important for computers, right? How much data it can process in a given amount of time. So it's given in units of millions of instructions per second, or MIPS. So how many actions, how many functions it can perform over a given period of time, or our period of time is 1 second. So the more functions, the more instructions a computer can process in any given amount of time, the more powerful the computer is. So this is determined by the speed of its internal clock, the clock that regulates the computer. You may have heard, especially if you game at all, you may have heard about overclocking computers before. That's making their internal clock run faster than it otherwise does, and giving it essentially more processing power. Clock runs faster, it thinks things are happening quicker, and it's going to do the act on the instructions faster. So a couple of units here, tera, giga, and mega. Right? Tera for trillion, giga for billion, mega for million. And hertz is a unit meaning how many hertz. You guys know from all kinds of different ways we talk about it, right? But hertz means cycles per second, right? In this case, we mean how many instructions per second, right? You guys will use it for like waves per second or cycles per second in AC, but in this case, hertz is being used to talk about how many instructions per second a computer can undertake. Terahertz, trillions of cycles per second. Gigahertz, billions of cycles per second. And megahertz, millions of cycles per second. So which is more powerful? Which is the most powerful of the three? Terahertz. Like if you had a computer operating 1 megahertz, 1 gigahertz, 1 terahertz, the 1 terahertz computer is the most powerful one. Good. Couple ways to classify computers briefly. So classification by size, right? A microcomputer, right? Single microprocessor, fits on a desktop, such as your diagnostic X-ray machine console. That's a microcomputer. Mini computer. Those are going to be found in more complicated equipment like CT and MRI scanners. They need to process much more data. CT and MRI, specifically like CT is just an X-ray machine that makes circles around the body as it moves along the plane of the body. So instead of taking one image, it has to take thousands of images, right? All at a very high rate of speed. And you guys are going to learn how we process digital images. And so you'll learn how much it really takes to process a single digital image. Well, that CT scanner is doing it thousands of times, and CT scans take like a minute, right? So it's doing a ton of images over a very short period of time. So it's going to need more processing power. So it's got more processors in it, more microprocessors. So they say, from anywhere from a cabinet-sized thing to taking up an entire room, even nowadays. That's a mini computer. Mainframe and supercomputers are those that take up entire floors of buildings. So you think just hundreds to thousands of microprocessors. And again, every microprocessor has a number of instructions it can undertake per second, and you just add more of them and you have more processing power. So that's what supercomputers do.